my name's Patrick Jamieson, and with me is Jaideep Majumdar.
Hello.
And we're going to be talking about a new capability that was introduced in 2024.1 called the FHIR Object Model. And I think you're going to enjoy this. How many in this room are back-end FHIR developers? Can we have a show? Okay, some of you. So this really will definitely apply to you the most, but everybody will learn something here. So here's my agenda for both of us. I'm going to give you a brief introduction. I'm going to talk about then some use cases, importance. We're going to have a nice overview of the FHIR model, and then we'll talk about, or I will provide a demo of how we could create a patient resource with this FHIR object model, wrap up with some conclusions, and get your feedback on some potential new features we might develop with this, and then take your questions and answers. So let's give a brief introduction to what this is. I think many of you who have worked with FHIR understand there's some challenges with it. If you've ever looked at the HL7 FHIR website, you'll see there's a lot of documentation. That's the real good news. The bad news is there's a lot of documentation. So you have a collection of structures, resource types, about 145 of them. But within those resource structures, there's a lot of data elements, we call elements in FHIR. So we have really over 700 resources in supporting elements, each with its own structure and data constraints. And so this makes it a non-trivial development problem. So part of your challenge, if you decide to accept it, is to remember the names, relationships, and the specific requirements of these numerous resources. This is absolutely a cognitive burden, and that's something we wanted to address. We wanted to make it easier to develop with FHIR applications and back-end FHIR applications as well, middleware with this. FHIR also is a directed graph. Now, what that means is it's not like working with relational data. You have essentially each FHIR resource type is a tree, but within that tree are nested elements. Many of them are objects or collection of objects. And there's some intricate relationships because FHIR can have references that point to other resource types. And I'll show you that in just a second. All of this means that navigating, manipulating these complex data structures can be challenging, and that's what we're trying to address with the object model. So let's just take a look at a typical patient resource. So if you go to HL7, you could go to a tab called JSON. You could see this single resource with all of the elements, and notice that some of these elements are actually objects like contact point or human name. We'll see this in the demo coming up. Within that, you also can see that many of these elements are arrays. And then finally, if you look down at the bottom, you could see like general practitioner is a reference to either an organization or a practitioner. So you have to keep this in mind when building FHIR objects or FHIR instances. Let's see how that translates in the real world. It'd be nice if we only had a single patient instance or a single patient object. But although the patient is the center generally of the clinical world, you might say, in electronic medical record, notice all the linkages to things like conditions, observations, medications, encounters. This is what really working with FHIR is about in a real world use case, you're going to have this very complex graph. And so basically having the tools to work with it are really, really essential. Now I'm going to let Jaideep give you a little bit more on the problem statement here.
Yeah. So we have previously solved part of the problem. We have the ability to read JSON objects into dynamic abstract objects. It's already available. Prior to 2024.1, it was already available for use. But while that makes it easy, you can manipulate the object. It's a JSON objects. You've got all the fields and everything. You're still on your own for a lot of things. First, navigating these FHIR structures. Pat eloquently described to us some of the challenges. Some of you who are programming with FHIR, you already know these problems. There's no guidance from the IDE because at the end of the day, it's just a block of text. So the IDE does not understand what these objects are, so it cannot help you. You have to know how to manipulate these objects, what those objects are, and so you have to constantly keep going back to the FHIR page, look at the specifications. There's of course no type safety that comes with that. There's no context-sensitive documentation either, so you don't know, as I said, nothing helping you out within the IDE. Most importantly, and is debugging. Like you want to trace, you want to see what variables are getting what values. You have just one block. You've got the dynamic abstract object. So you're quite a bit on your own. Other common challenges are creating boilerplate code for these common tasks like allocating all these nested objects. You're creating them, you're attaching them, then navigating through them. You're dealing with various different data types as you're dealing, like going from patient to providers, claims, medication, everything. And finally, converting between various data models. You may have data coming in from legacy systems. It could be HL7, it could be something else. You're reading it in, you have to kind of process it, handle it. So it's a lot of work for developers, and that's why we want to, this whole thing tries to solve this problem. Our solution is to have classes, object script classes that are generated and is distributed as part of 2024.1. We have distributed the base classes from the FHIR specification. We have an object model generator, which allows us to stay in sync with the new specifications as they keep coming up. Because today we have generated the R4 classes, but it gives us the possibility of implementing others depending on where the market is going. Certainly it makes our life a lot easier to not have to create the classes from scratch ourselves. This model generator actually goes through the FHIR specs and it generates these classes and gives them intuitive names. By that I mean it gives it the same names as the resources, so you can see a one-to-one correspondence between them. And it actually even reads the documentation that comes with it, and includes that in the documentation of the classes and all of the properties and everything. So it fills it all out so that it's available for you as you're doing the development. So from the big set of resources that is there on FHIR, I've shown an example of like some base resources and some clinical resources. And what we generate out of that are corresponding resource classes right there. Now, this generator generated 1,079 classes for R4. You know that there aren't those many resources So why 1079? It's because, as Pat was showing, those objects have inside them other objects. Sometimes they are references to other resources, in which case it's a directed graph. But other times there are embedded objects that are specific to one resource. And so accessing that, it's a multi-level access. So for that, this class makes it convenient by generating those classes for you. So that's how it is done. And as we go for R5 or support for profiles and others, we are going to use this generator, enhance that, and implement others. Certainly, we could not have generated 1079 classes by hand. So it's a big deal for us and to make it available for everyone. Again, intuitive naming conventions. We're trying to follow the same naming standards as in the FHIR specs. They are classes. That means when you are in the IDE, now you've got auto-completion support. Patrick has a demo for that later on. Most importantly, this is where we find the most value, debugging. They are variables. You can see the values. You can see the value of the object and the sub-objects inside it, and you can actually verify whether you got them all correctly. And finally, the documentation that comes with it. So these things are providing support on multiple fronts, being able to construct all the various nested structures, allocating them, assigning them to the right resources, building up the tree. The ability to navigate the tree, and we will see a little bit of it in a few minutes, in an object agnostic way. We already talked about the benefits of integration with the development tools, and finally using these classes to build modular solutions. So you have these available. Now Patrick is going to go through some of the use cases of these classes.
Thanks, Jaideep. Yeah, so if you're a back-end developer, there's a lot of good use cases for this technology. So one of the things, both with either Iris for Health or Health Connect, that you could do is FHIR data synthesis and composition. So you could see taking in some resources from a legacy data source or even a FHIR source, and then programmatically building other types of FHIR payloads that you might send off for some kind of data exchange or submission. So you might, for example, create a FHIR claim resource based on patient encounter data, perhaps from something like a HL7 message. So you could also do FHIR data transformation and mapping. So we could convert FHIR resources between different resources and conformance profiles. So profiles are critical in building real-world FHIR applications. You can basically do a number of checks to make sure that it's consistent with the profile. You could even create default values. So you can map FHIR data from any kind of internal data model or proprietary format using the programming language embodied with the FHIR object model. So you might want to transform a FHIR bundle from some third-party system to be compatible with an in-house EMR system. Data validation quality assurance is critical for building real-world applications. You're going to validate your payloads. We do offer a FHIR profiling support, but you could do more, even more, with actual programmatic validation and enforce all kinds of data constraints and business rules that might be characteristic of your organization. So you could verify a FHIR observation resource adheres to a specific value set, contains all the fields that you wanted to see in that incoming payload. you could combine data from many sources, and maybe you do this for the purpose of data visualization. You could take that fire data that's coming in and then map it to different structures that would be useful in visualizing things like the fire encounter condition and observation rate sources all together on a dashboard of some kind. And finally, you could build a fire facade. I don't know how many of you are familiar, but many EMR systems, they don't store fire data natively. What happens is they're getting fire requests through the Fire API and then assembling from their internal data sources fire payloads that they're sending out. And they could be sending them out to any kind of fire compliant mobile application. So this would be really critical if, for example, you're not using a fire repository. You could use a FHIR object model to assemble fire payloads that you could then send out to your application. And with that, I'll let Jaideep talk a little bit more about the object model.
Thank you, Patrick. So now, this is the part of the presentation where I put you all to sleep. We're going to dive a little deeper into the FHIR object model. Thank you. So the FHIR object model is based on a new set of classes that we call the abstract set. The abstract set is based on the concept that at the end of the day, you have basically two types of collections. You've got sequences, ordered lists, arrays that you access by position, 0, 1, 2. Or you've got unordered named objects, like maps, like key value pairs. Those are, if you boil down all those kinds of representations, linked lists, arrays, everything, at the end of the day, it boils down to just these two major things. And so, having a common interface to handle either of those and being able to represent all of these objects and be able to add elements into it and being able to navigate elements makes it easier to kind of navigate through this complex FHIR structure. Or for that matter, other structures. If we go out of FHIR, you want to deal with HL7 objects or other objects, you still have the same concept. So the foundation that we are applying is this abstract set, which has a small set of operations. Get, to get values. Put, to assign values. Those who are familiar with other languages like Java and others are also must be very familiar with all these terminologies. You can remove elements from a list. You can apply. The apply, what it does, it allows us to kind of access. It's like a query language, and I will get a little bit into that. It allows you to address a whole bunch of nodes at one time using a search pattern. Previously, I showed that we had the ability to kind of load data into dynamic abstract object. With the abstract set, it's possible to take those dynamic abstract objects and to instantiate class. So you have the ability to convert any object from dynamic abstract object into classes and back. And of course, you have the ability to add elements and finally iteration. So all of the new generated classes implement this interface, so that makes the operations familiar for everyone. So I'll dive a little bit into these advantages. So the abstract set, as I said, is not dependent on the implementation. We have the same set of implementation for globals and classes and all. With registered objects as well as dynamic objects, they have the same interface. You work with them the same way. And then we have built an abstract set query language, which is based on the ISO standard. It's compliant with other languages like JSON path, if you're familiar with that. It's also more generic than FHIRPath. And so that allows you to kind of use the power of that language to access multitudes of nodes and to walk through all of them. I'm going to get a little bit into that, but that's a topic by itself. So I'm not going to dive very deep into the abstract set queries. You access data by using the get operator. So a patient has a name. FHIR allows you to support multiple names for a patient. So you are accessing a name using get 0. So give me the name at the first location. You can also access named elements like patient ID value is you are getting the patient's identifier and getting the first entry, and then you are getting the value out of a key value pair. So you see the same get interface supports both a positional access as well as a named access. And that is sufficient to access all of the complex FHIR structure that Patrick was showing earlier. I was just trying to scare you. We have the solution to be able to handle that. We have methods like contains that will allow you to check for existence of elements before accessing it to avoid blowing up with a null pointer exception. And of course, as you would expect, there are ways to assign values. They're using the put operation to kind of assign name value pairs. So objects have multiple types of entities underneath them. There could be scalar entities like numbers or strings, which you can just do a put, as I showed in the previous slides. But if it's a more complex object, then the put by itself does not work. There's a reason for it, and because we made a convenience method to do that. And that is a directive that is called the include directive. So when we do a patient and do an include address, it actually instantiates the right type and associates the address object with the patient. So that's the direction we are headed in. So the example here shows that we have got ourselves a claim. Then we did an include type that actually created a type element inside it, which is an object. And then we do an include coding. So then under the type, it's going to create a coding object, and so on and so forth. So there are a whole bunch of appropriate methods that are available. And why is this important? Because like when you are in the claim object, you have the include type method available. You don't have the include coding method. So you just from the set of methods that are made available to you, you are restricted to the types of objects that you'd want to instantiate rather than kind of guessing. So you will see, this patient claim this has an include type, so there must be a type object. So those are kind of, even without being able to give you the full solution of knowing all the FHIR objects, it's kind of providing you hints as to the kind of objects that are there, and at least reduces a few trips to your FHIR specs. Navigation. I wanted to show you the navigation using an iterator pattern. Again, it's a familiar pattern. We read about it in the Gang of 4 books in design patterns. It's available in languages like Java. The iterator pattern says, independent of whatever is the type of objects, as long as I have an iterator, I can walk through it. I can do a get next. And I can check whether there's another element. So I've got a has next. So I can use that same pattern to walk a set of named objects, and I can walk a set of sequences. And I don't have to know how many elements are there in the array. I can just loop through and let the iterator handle it for me. Again, it helps with handling the various types of objects that you're dealing with in FHIR. Here is where the conversion of objects from dynamic abstract objects, we typically call it DAO. So conversion from DAO, and there are ways, similarly, classes have to DAO to be able to convert these objects into JSON. Pictorially, this is what happens. FHIR document read into dynamic abstract object. We already have a very fast implementation of dynamic abstract object instantiation. We are taking advantage of that and just building on top of that the ability to instantiate the classes from these dynamic abstract objects. And the reverse direction, you go from classes to DAO to the JSON XML, which you can then use for various, you could actually store the data as JSON. You could have a REST API that returns answers in JSON. You could use it in any way you like. An important aspect of these FHIR object models is that they are derived from registered classes. They're not persistent objects. And that means that you are able to use these classes to implement your implementation of however you want to store. You don't have to store your data as FHIR. You could store it in HL7 or any other proprietary format that you're dealing with. A quick example of a claim including type, include coding. Coding underneath has more coding. So just a reiteration of something that I already talked about. A little bit about the abstract query language. As I mentioned, it's based on the JSON path language. The structure of that is, it's a tree structure. The root of that is the $. And with the brackets, you are addressing a condition. So a star means every element. So using this expression, you're saying, from the root element of my FHIR tree, give me all the immediate children of this node, and give me all the resource elements within those nodes. So this is just one example. You can make arbitrarily complex expressions to implement this. And it gives you a way, again, you would combine such a query with an iterator. So again, depending on your query, you could be finding, you don't have to walk the objects in that hierarchy of FHIR. Depending on the query, whatever results you get, you say put an iterator on top of that. And now you can walk your result set without doing the structure. So you could be thinking about your solution rather than the structure when you're using this. So some key takeaways is that abstract set opens the door for a more business-oriented work. Think less about the structure, think more about the value, the data, and navigate in a constant way. Common APIs that are easy for you to handle and provides seamless access across different types of objects. Now over to Patrick for his demo. He's been building some code to try it out.
Thanks, Jaideep. Yeah, I thought you would appreciate seeing a short demo of just how you would use this in action with Visual Studio Code. So I'm going to start up this demo. It has been pre-recorded, so it will work. But I wanted to point out a few things here. Here is that FHIR patient resource we saw, and we're going to look at some of these elements. For example, we're going to look at the name element and look at human name. It has a lot of other sub-elements. It has a sequence of strings, for example, for given name. If we go back, we'll see that and there are many other fields. Okay, so here we're in Visual Studio Code, and I'm dimensioning this so I can get the support. Notice you're seeing on the right-hand side auto-completion taking place, it's telling us what are available when we've typed just in the first few characters. So I'm going to create a new patient. Now, I want to include one of those abstract elements in FHIR, the name. We know that that's an object I just showed you, and I want to make an entry. We need to make an array of names. So I typed make entry, and I'm going to have the first name as John, and I'm going to now include given names, which is a sequence of names, and I'm going to set that the family name to Doe, and I'm going to add that first name into the name object. So now let's go and look at including address. And you could see I'm getting a lot of support from the IDE. I've got color coding. I'm making an array of address objects. And I'm going to include line, which is one sub-element of the address array. And so I'm typing just 123 Main Street here. I'm going to add another line. I'm going to add that line into the array. I'm going to now set that address, the address city, Boston, set the address state to MA. And you see, again, we're seeing all that support. Postal code, I'm going to add that in there. And I'm going to add this into the address array. So now I'm doing this again with the contact point. And again, you see a familiar pattern just emerging. Taking each one of these objects, and I'm creating entries for them, and I'm including elements, these sub-elements like telecom, where we're going to make an entry because that is an array, and we'll give the system. We'll type the value of that phone number, the use of it, a mobile number, and add that into our array of contacts. And finally, we're going to look at the identifier. Now, the identifiers, we're actually pushing it in from our function here. We're going to make an entry for that. And here I'm using this make coding where I'm going to, this is a convenience method we have where I'm going to set the system for the coding. So this is the system I'm going to be using, and the value of that system coding is medical record, or MR, and I'll add that in there. And then I'm setting the ID type to coding, and the identifier is coming from a parameter into creating this patient. So I'm adding this. Now I'm using the toDow method. So I'm creating now patient JSON, and I'm going to use the rest of this to just push this into a FHIR server that has already been up and running. I'm going to use the interactions class to do it. There's other ways, and I'm going to execute that. And we'll see that at the end. But here I'm going to go into debug. This is what I wanted to show you, how powerful this is. I've entered a value for the identifier 222. Now notice as I'm walking through this code, on the left-hand side, I could see all of the elements, the FHIR elements, and their values as I'm walking through the code. So let's see what happens when I do the first name. And you could see that is a given name, is a sequence of strings. You would not normally know this. And here I got the birth date. So if we look here at the we could see that we have a dynamic array there, including the line. The line is going to be under the address, and see that is a sequence of strings, and we could see that very clearly. We could see that the address is a list. And again, we could see every one of these values as we're going through this. So here I'm going to take a look again at telecom, and you can see I've instantiated several of these values. So I go through here, and I'm going to include an identifier, the coding, the value, and I'm going to add that identifier to the patient. So let's go down there and look at identifier, and we could see this is a sequence of identifiers. And we could see, again, the type, the coding, and we could see the system and the value. And now I could also push this to our FHIR server through this interactions class, and let's see if everything worked out. Here I'm in Postman, and I'm getting the value. Notice I sent in the value in my function of 222, and so now you see I've converted this from FHIR classes to a what? To a dynamic abstract object that could be posted to the FHIR server very easily. So let's wrap up with a couple conclusions here. First, the object model makes it easier for any back-end developer to work with FHIR. I hope we've convinced you of that it's going to be easier to work with these classes, especially given the IDE support. We're unifying dynamic abstract objects. Dynamic abstract objects were created effectively to make our FHIR server very efficient. That's why we used it. But now you could use either dynamic abstract objects or FHIR classes, and you could basically use them interchangeably because you can convert from one to the other very easily. This offers a mechanism for future enhancements such as FHIR profiling, because we could generate those classes. And it works very, very well with the Visual Studio Code environment. So what I wanted to do now is just kind of get a feeling from the audience here about how we should exploit this in development in terms of the future. So what I'm going to ask you is a show of hands. Here are four different types of projects we could work on for the next year. And what I'm going to ask you is just to raise your hand when I call it out for only one of these, so we could get an idea of what is the most important thing for this audience. So here are the choices. The FHIR R5 model classes we could generate. FHIR profile model classes, so you could select a profile, we could generate that profile. Config different transformations using our new abstract set query language, and converting native CDA FHIR support in our DTL editor using the FHIR object model. So let's start from the top. How many of you think we ought to work on FHIR R5 model class generation and support FHIR R5 with this FHIR object model? Okay. How about FHIR profile model classes? How many think we should do that? All right, how about config-driven transformations using the abstract set query language? And how many for conversion of native CDA FHIR support in the DTL editor? All right, well, I think we got our answer there, Jaideep. There are some useful courses that you could follow up on this. There's not a course on the FHIR object model, but we have things on FHIR facade and simple FHIR facade that are highly related to the FHIR object model. If you're building these facades, it'd be useful to learn this. There's a lot of other sessions at Summit on FHIR I wanted to point out. The Tech Exchange has a lot going on today. I'd urge you to stop by and check out one of these sessions. I think they'll be very interesting. And tomorrow we have a lot of great content on the FHIR SQL Builder, lessons in the field, and just a lot of interesting material. I think if you're an enthusiast about FHIR like I am, you should really try to make all you can I'll be talking about fire performance benchmarking tomorrow evening. I'd be happy to see you there. And with that, we'll open it up for questions. Any questions? Okay, maybe I'll go and bring my mic over, Jaideep, and I can talk loud. No, let's talk into the mic.
Sure. I think I missed on one of the first slides. Was there an actual class that would be created for the bundle resource?
I believe so.
So you'd be able to iterate through the resources in a bundle?
Yes, yeah, I'm almost 99% positive, right? Yeah. Our developer who built this agrees. Any other questions?
So if I followed based on the future work you were suggesting, you only support base R4, no implementation guide support. So if you're doing anything outside of R4, you're not using this yet.
Yes, we're only supporting base R4 with the generator. Now, you know, you could build your own classes, right? You don't need our classes, but yeah, for this generator only supports base R4 currently.
It's a somewhat related question, but how much work does it mean for InterSystems to adopt a new version of FHIR based on this object model?
Go ahead, JD.
So because essentially the generator drives is off of the specifications, it's relatively easy for us to kind of support a new FHIR version. For example, it's going to be relatively easy to implement R5. In fact, we have that in the works. A little bit more work to do the profiles because those are more custom values, and there are a lot of different profiles, for example, US core, Australia base, and so on, and each of them has their own definitions. But it can be written generically such that we can drive it off of various implementations. In short, very simple for base cases, a little more complex for profiles and others, but still a lot easier than doing it on your own.
Other questions? All right, I think we're going to wrap it up. I really appreciate your coming out, and if you do have any other questions, feel free to come on up, and we'll be happy to talk with you. All right, take care.
Thank you.